Okay, so this question says, determine the exact value for theta for the triangle shown. Now, when we throw in those words exact value, that's sort of pushing me towards, well, I'm starting to think that this is going to be a special triangle, or the ratio that I'm going to get for that theta is going to be a special angle. So although the calculator could be used, and I don't deny that at all, the calculator could be used, the intention of this problem is that you're not going to use the calculator. So when you get a triangle where you're given all three sides, can't really verify whether this is a right angle triangle or not, but I can figure out theta by using the cosine law. So theta is going to be the inverse cosine, and I draw my big set of brackets here. I'm going to fill this in. Okay, I've got a numerator. I'm going to put the numerator and denominator in brackets here. And now I'm going to fill in the pieces here. I just have to be careful. When I'm looking for theta, when I'm using the cosine law, okay, I look at the side opposite the angle that I'm looking for, and that's the one that I'm going to subtract up here. So it's going to be minus 2 root 7 squared. And now I'm going to put the other ones in here. So this is going to be bracket 4 root 3 squared plus 10 squared. And then down here this will be 2 times 4 root 3 multiplied by 10. Okay. Well, although I could jump to the calculator right now, that's not the intention of this question. The intention of the question is that we're going to work this thing through. We're going to simplify it and leave everything in exact forms. We're not going to let the calculator handle it. So I got to go through and evaluate this. Now, so the first thing I want to look at here is the 4 root 3 squared. Now, I know that it's a very common thing for people to do this one wrong here. A lot of times what people will do with this is because of that square, and they'll look at the square, that square root of 3 there, they'll go, oh, okay, I know what happens there. The square gets rid of that. And oftentimes the number that people write here is 12. But they write 12 because even though they squared the root 3, they didn't square the 4. And you need to square both. You need to make this 4 squared and root 3 squared. Well, 4 squared is 16, root 3 squared is 3. So that answer there is 48. Okay, 10 squared probably isn't causing the problem. 10 squared is going to be 100 here. Minus, okay, 2 root 7 squared. We got to do that too. 2 root 7 squared means the 2 is being squared and the root 7 is being squared. Don't forget about the coefficient. So it's going to be 4 multiplied by 7. And so the answer is 28. So notice that all the roots disappeared up there. The square roots are gone. Down in the denominator, I'm not going to have the ability to do that because there's nothing down there that's going to square that root 3. It's going to cancel it. So I've got 2 times 4 times 10. So it's going to be 80 root 3. Okay, now we'll just keep going here. We'll just keep simplifying and hope that something nice pops out at the end here. So 48 plus 100 minus 28 is going to be 120 over 80 root 3. Okay. Well, that's actually kind of nice. That actually works out okay because 120 and 80 are both divisible by 40. And so that's going to be 3 over 2 root 3. Okay, well now I'm getting some really nice friendly numbers here. But I don't recognize that as a ratio that goes with my exact values. Now, I mean, I do. But it's not going to be obvious to a lot of people that that's the way that works here. So what I want to do here is let's grab a different pen here just to show that this is kind of in addition to this. What I'm going to do is change the way this one looks. I'm not going to change the value. I'm going to change the way it looks. Notice that I've got that radical down in the denominator. And I'm not really used to that. Okay, when I look at the exact form, most of the time I don't have that radical down there. So I'm going to rationalize. This is a really common thing to do here. We're going to rationalize that. So we're going to multiply by root 3 in the denominator. But if I do that down here, I got to do it up here too. Okay, because I have to do the same thing to the numerator and denominator, or else I did change the value, and I don't want to do that. I don't want to kind of randomly change the number as we're moving through this. Now, the numerator is just going to be 3 root 3, but in the denominator, root 3 times root 3 is 3. I'm not, in this case here, I'm only squaring the root 3. I'm not squaring the 2, so this becomes 6. And now, well, that 3 over the 6, well, that simplifies down quite nicely. That becomes root 3 over 2, and I recognize that. Okay, I recognize that from the special triangles that we would have looked at in a previous lesson here. And I know that that's going to be 30 degrees. Okay, so that's what we wanted you guys to do. Okay, so for this problem right here, it's because we asked for an exact value. Yeah, you could have plugged that into calculator. Nope. Wanted you to go through and play with it, do the algebra there, and get it down to that ratio right there, and show that you know what that angle is.